In the second episode of The Weldicator, I'll show you which factors lead to increased spattering in the dip transfer arc and how you can avoid this. I'd like to split these factors up into 4 categories: welding equipment, welding torch handling, material preparation, and alternative welding processes. Welding equipment that's working efficiently forms the basis for stable arc. The welding torch and return lead cable need to be firmly connected to the welding system to ensure there's a reliable current flow. The same goes for the grounding on the component. The fastening point and earthing clamp must be bare and boast excellent electrical connectivity to allow current to flow. Consistent wire feeding is another prerequisite for a stable arc. 2 things are vital to guarantee this. First, the hose pack must be laid without any bends if possible. And secondly, the contact pressure on the wire feeding rollers must be adapted to the wire being used. Too little pressure can cause the wire to slip through. An adequate gas shield as well as the correct gas are both crucial too. As a rule of thumb, multiplying the wire diameter by 10 provides the gas flow to be set in liters per minute. Mixed gas is used for most steel applications. Wearing parts such as wire spools, inner liners, and contact tips must be chosen to match the material and diameter of the welding wire. If they already exhibit too much wear, this can result in an unstable welding process. The choice of welding parameters can also lead to spattering. This is particularly true if you set a power range that's in the intermediate arc. In this case, the power should be corrected with a view to entering the dip transfer arc or spray arc. Material preparation is no less important. The material must be cleaned before it's welded. Dirt, rust, oil, scale, and even zinc layers on galvanized steel need to be removed from the welding areas. The way that the torch is held and guided is also key to a good welding result. The welding torch should be tilted at an angle of 15 degrees in the welding direction and guided at an even speed. The distance to the component, otherwise known as the stickout, should also be kept constant. If this distance is too great, the gas shield and penetration will deteriorate, resulting in more welding spatter. Provided you take all this into account, you have a very stable dip transfer arc. If you need even more stability and want to reduce spatter even further, you ought to think about switching to a more advanced welding process. The modified dip transfer arc LSC is ideal here. That's it for today. See you in the next episode of The Weldicator.